In this problem, we are given a function for velocity of particle, and we want to, in first part, we want to find the displacement of a particle over this interval from 0 to 5 seconds. And in the second part, we want to find the total distance traveled by the particle at the same interval. So very important thing that these two are very different from each other. So if a particle is moving to this point and coming back to the same point, the displacement would be 0, but the total distance traveled would be whatever this length is multiplied by 2. So basically kind of the number of centimeters, the number of meters that it kind of traveled, it walked or it moved. So velocity is basically, I just write it here, velocity is rate of change position. So it is basically how fast position is changing. So velocity is basically the derivative of the position of an object. So to get the position, to get the displacement, we need to undo that derivative. So basically, we can say the displacement is the integral of velocity. And this would be a very simple problem. So the displacement, let me just write displacement here. Displacement is integral of the function velocity on the interval that we are analyzing that. It's from 0 to 5, so it's from 0 to 5. And the integral would be integral of the function t to the power of 3 minus 6t to the power of 2 plus 8t dt. So we have three functions here, which all of them are power functions, very simple functions. T to the power of 3, it would be t to the power of 4 over 4 minus the integral of this function would be minus 6, and t squared would be t to the power of 3 over 3 plus 8t, which the integral of that would be 8t squared over 2. We can simplify that, but after that we need to plug in the upper bound and the lower bound. The lower bound 5 as 0 and the upper bound 5. So let's just plug in the upper bound first. So it would be 5 to the power of 4 over 4 minus 6 multiplied by 5 to the power of 3 over 3 plus 8 times 5 to the power of 2 over 2. This is the upper bound minus when we plug in the lower bound. It would be 0 to the power of 4 over 4 minus 6 times 0 to the power of 3 over 3 plus 8 times 0 to the power of 2 over 2, which the second bracket, this part is entirely 0. So overall, this would be the final answer, which we can simply evaluate that, and we can simplify that as well. So the 2 and 8 can be reduced to 4, 3 and 6 can be reduced to 2, and here we cannot simplify anymore. And if we evaluate that, at the end we would get 25 over 4. This would be the displacement of the particle over this time from 0 to 5. So we basically just take the integral. Let's take a look at the graph of this. And before moving to total distance traveled, let's take a look at the graph of v of t. So to sketch that, or to see how it behaves, v of t, let me just write it again, t cubed minus 6t squared plus 8t. Let me first factor it. So first I will factor one t out from here. So if I take a t out, I would get t squared minus 6t plus 8. And I see that I can factor this one further. So I can write it as, okay, I'm looking for two numbers which are added to negative 6 and they are multiplied to 8. Those two numbers can be negative 2 and negative 4. So I can write that as t minus 2 and t minus 4. So this is a factored version of this function. And the reason that I factored that is it helps me to find out when it would be 0. It would be 0 when t is 0, when this bracket is 0, or basically t is 2, and when t is 4. So this function has 4 roots. And let's take a look at the graph of that just roughly. So the graph of this from 0 to 5. So this is 0, 1, 2, 3, 4, and 5. So we know that it has roots at 0 at this point, at 2, and at 4. But what's the behavior of the function in these intervals? To analyze the behavior of the function, what I do, I draw a number line and I just put the roots here, 0, 2, and 4. And I simply plug in numbers between 0 and 2, for example, like 1 into this function or into this function. They are same functions. So when I plug in 1, I get 1 here, I get -1 here, and I get -3 here. And when we multiply these three numbers, we would get a positive number. So we know that between 0 and 2, the function would be positive, which means it's above the x-axis. For between 2 and 4, same thing. If we plug in 3, it's positive here, and negative here. So overall, it would be negative. And above 4, if I plug in 4 here positive, and here positive, all of them would be positive. So the behavior of this function is kind of like this. It's above the x-axis, and between 2 and 4, it's below the x-axis, and after 4, it's above the x-axis. So this would be the overall kind of very rough sketch of a function of velocity. And it's from 0 to 5 seconds, or 5, I think the unit is seconds. Yeah, so it's the unit is second. From 0 to 5 seconds. But what does positive and negative velocity mean? Whenever the velocity is positive, it means the particle is moving toward the positive direction. You can assume that, okay, the right side is a positive direction, or going up is a positive direction. It really doesn't change the whole story. So for example, let's assume that going to the right is a positive direction and going to the left is a negative direction. Is a negative velocity basically, or negative direction. So when the particle has a positive velocity, it means it's going to the right. So the particle is going this way. And for example, after 2 seconds, it's here. After 2 seconds and all the way to 4 seconds, the velocity is negative, which means the particle is going back. Maybe up to here, maybe exactly the same place, or going further back. Really, it doesn't matter. It's just going back. And after 4 all the way to 5, it's again going to the right side. So the displacement is basically only where it was and where it will be at the end, which is the area under the curve. And because this area is negative, which means the particle is going back, it is canceling some of the areas, some of the positive areas where the particle was going to the right, which makes sense because the particle was going to the right, but it's kind of undoing everything. It's going to the left. It's canceling. But for the other part, for the total distance traveled, for part 2, doesn't matter if the particle is going to the right or going to the left. The total traveled, distance traveled, it would be the summation of these lengths, and these lengths. So we don't care if the particle was going to the left-hand side or the right-hand side, if it was going to the positive direction or the negative direction. To kind of have this in our equation, so we said that the displacement is the integral of velocity. The total distance kind of traveled is basically the integral of absolute value of v of t. But why absolute value? Because absolute value makes the function positive. So this part which was already negative, absolute value would make it positive. So yes, the particle was actually going to the left, but because we want to find total distance traveled, we don't care about it's going to left. So we care about just how much it was moving to the left, to right, whatever. So this would be the formula for total distance traveled. But how should we deal with the absolute value? So basically what we did here, finding the zeros, is the key to answer or to take the integral of absolute value. So we know the function changes behavior at 0, at 2, and at 4. So we simply break down the function into 3 pieces. So the integral from 0 to 5 of absolute value of v of t dt can be written as the function from 0 to 2, the first interval, absolute value of v of t plus the second interval, which is from 2 to 4, absolute value of v of t dt, and the last interval, which is from 4 to 5, v of t dt. So in the first interval from 0 to 2, if we take a look at the function, erase this part. If we take a look at the function is already positive. So basically, absolute value doesn't do anything. So we can simply get rid of these absolute values. Let me actually copy paste that. So here to reference, refer to that. Okay. So here, absolute value basically doesn't do anything. We can get rid of that. What happens from 2 to 4? From 2 to 4, because the function is already negative, absolute value actually does something. It makes the function positive. How absolute value does that? By multiplying the function by another negative. So basically, instead of having absolute value, what we can do, we can multiply our negative function by a negative sign. So it basically compensates that absolute value feature. Now, this is a positive function. And from 4 to 5, because the function is already positive, it's above the x-axis, absolute value again doesn't do anything. We can simply get rid of it. So basically we have 0 to 2, from 2 to 4, and 4 to 5, and just 2 to 4 would be have a negative sign. So what is the integral? So first we take the integral, and actually we took the integral already here. The integral is, where is that? Here. So we have the integral. So let me just copy paste that. This would be the integral. For the first part, it would be from 0 to 2. Plus, or kinda, I can take out this negative. So I can say just plus a negative or minus overall. The second integral, which is, the integral would be same thing, just the bounds would be different, from 2 to 4, and plus the third integral, which would be, again, the answer of the integral. The result of that is same, just the bounds would be from 4 to 5. So this would be the final answer for the total distance traveled. And we can evaluate that, and the result to that would be, for the first part, the answer would be 4. For this part, it would be -4, which the reason is the particle was going to the left hand side, it was going to the left, but this negative would make it positive again. So we have 4 minus -4, and the last part would be just 25 over 4. So the key here is this negative would be converted to a positive number. So at the end, we would have 57 over 4 as a final answer.